Okay, so thanks. So today I'm going to be talking about the different kinds of physics tests that are out there. So the AP physics test versus the SAT physics test, and then the different varieties of SAT physics tests that are out there. Then we'll go through kind of some example problems to illustrate the differences, and then how we offer courses to address the skills and the concepts that you need to know to be successful on all the physics tests that you may need for getting into colleges and whatnot. And then we'll talk about some tips and some frequently asked questions as well at the end if we have time. So question some people might be asking, should I take the AP physics or should I take the SAT physics test? So AP physics is typically, a 1-year course or multiple years if you take different physics classes. So it's a test that you would take in May at the end of the school year after taking a full year physics course. So they have specific content and methods that aren't necessarily covered in a normal high school physics course, like a general physics class or an honors physics. The AP physics courses are very directed and structured towards a specific laboratory skills, towards specific labs and specific content that will be tested on the test. So they focus on problem-solving skills and also laboratory skills. So not just knowing the concepts that you would need to be successful, but knowing how to apply them in a laboratory environment, knowing how to problem solve through a situation that you've never seen before in order to use the skills that you have throughout the year. The physics test is unique in the AP world because there's 4 different physics tests. If you were going to take, AP chemistry, there's 1 AP chemistry test. For physics, there's 4. So there's physics 1, physics 2, and then physics C, which is actually 2 separate tests, which is mechanics and then electricity and magnetism. And so all these tests are useful for college entry exams or college entry. Also, you can also earn college credit depending on the school. Some schools don't take AP tests at all, but others will give you credit between 3, 4, 5, depending on how well you do and depending on which test you take. So you'd have to contact a specific school to find out how you'd earn credit for that. SAT physics, on the other hand, is not geared towards a single course the way that AP physics is. You could come from any different high school physics background to take the AP physics or to take the SAT physics test. One of the things about SAT physics is that it's a much broader knowledge base. So whereas AP physics tends to be deeper, SAT physics is broad. So there's usually some content that the students haven't learned in high school at all. So it's one that requires some preparation, especially to kind of learn about the things that you might not have learned in your high school physics courses. Whether or not, even if you took multiple AP physics courses, there's still probably some things that you haven't learned that need to be addressed before you take the SAT physics test. The structure is also a lot different versus in the AP physics test. They have kind of like I said, problem solving and kind of laboratory skills, as well as like solving for specific answers. Versus on the SAT physics test, it's more short recall and short calculations. They don't have calculators at all on the SAT physics test, so it's all simple calculations that you'd be able to do. And it's a lot of just content recall. Do you understand this concept? Is there a way we can kind of trick you to see if you really understand it? But the questions are much faster and and there's a lot more of them than there are in the AP physics test. And it's more used to demonstrate a high level of content knowledge for college entrance. You're not going to receive credit for the SAT physics. You're not going to receive college credit for it the way that you could receive college credit for an AP physics score. So, and like I said, so there's 4 different SAT physics courses. So there's Physics 1 and 2, and then the Physics C exams. So the Physics 1 and 2 are fairly new courses. It's only a few years old. That they used to have A, B, and C, and then they got rid of A, and then they basically replaced B by Physics 1 and 2. So Physics 1 and 2 are algebra based, so you don't need to know calculus necessarily. It could be helpful, but you don't need to know it to answer any of the questions on the test. They focus a lot on processes and skills. So the skills part is actually more important than the concepts that you know on the Physics 1 and 2 test. So they're going to use the kind of the same processes over and over again. But what they're looking at is can you look at this information that we give you, use the skills that you've learned throughout the school year and apply them to solve this problem that you haven't seen before. Laboratory equipment, laboratory skills also play a very large role. They'll basically ask questions that depend on specific pieces of equipment that you wouldn't necessarily use outside of an AP classroom. And they'll ask about, procedures. They have questions that are specifically, create a procedure, that sort of thing. Physics 1 is an introductory physics course, so it doesn't assume that you know anything going into it. It could be helpful to have taken a physics course beforehand, but they don't assume that you have any prior knowledge. Physics 2 basically builds on Physics 1. It's mostly new concepts, but it's going forward. It's also an algebra-based course, so there isn't a need for calculus in that one either. So Physics C, on the other hand, is calculus-based, so there'll be questions that might not say, take a derivative or an integral, but it's just assumed that if you know how to do these processes, that you'll be using calculus to accomplish those things. So there's the mechanics test, 2 separate tests, and then there's the electricity and magnetism test. A lot of times, a lot of high schools will just have a Physics C course that's like a full year course, and it's going to cover the mechanics and the electricity and magnetism, and so you would be expected to take both at the end of the year. Other places, it's just a mechanics course or just an electricity and magnetism course. So they focus on problem solving, especially. They have much more like quantitative answers, like if your answer be 4.5 instead of on Physics 1, it's more of a comparative thing. And then they also use laboratory and process kind of questions, but not in the same way. It's much more mathematically rich and calculus based, as opposed to skills and comparison, kind of like it is in Physics 1 and Physics 2. So just to give you some examples, so here's a typical Physics 1 multiple choice question. So there are there are more conceptual questions. Like, for example, on this one, it talks about a child standing on this merry-go-round, and it's talking about how is the child moving its location on this merry-go-round going to affect the angular momentum. So the questions also involve quantitative comparison. So instead of having the child and the circular platform both have exact masses like 1 kilogram and 5 kilograms or something like that, it has mass m and mass 5m. So that's pretty typical for the Physics 1 and Physics 2 types questions. They're also, the Physics 1 questions are they're kind of longer. That requires a lot more reading. It's that all of these answers are at least a sentence, if not almost a paragraph. And they rarely ask for numerical answers. So looking at this question, we'd read through this question. For the sake of time, I'm going to kind of go a little faster through it. But so the question asks, which of the following describes an action by the child that will result in an increase in the total angular momentum of the child platform system? So having gone through all of the concepts up to this point, I would know that basically the angular momentum of the system will be changed if an outside force is applied. But the question asks an action by the child that will result in a change in the increase in the total angular momentum of the system. So in other words, there's no way that the child can do something that would change the total angular momentum of the system because the child is part of the system. There would have to be an outside force acting on that. So from these answers, I know that none of the actions described could change the angular momentum of the system. So as we're going through in the courses, we would read through these problems. Each student would have a chance to try the problem on their own, and then we'd go through it together. So for a physics C multiple choice question, you can see it has kind of a different structure. The answers are in more of an equation form, and there is a lot of crossover on these types of questions between the two types of tests, but this is more indicative of the physics C type questions. So obviously there's more calculus involved. It's more equation heavy, and then the answers tend to be more numerical, or in this case, the answers are equations. So looking at this particular equation, or this particular question, it asks a question about basically finding the potential energy U given the equation for the force F. And so then I would have to know, to answer this question, the relationship between potential energy U and force F. So that relationship is that the potential energy equals negative the integral of force with respect to distance. So then we would integrate the force equation given in the problem with respect to x, and so using the power rule, we get 1/4 kx to the fourth, which is one of the answers that we're given. So this is a fairly simple and straightforward question if you know the principles involved, and if you have the calculus skills to accomplish it. All right. For the free response questions, there's more of a similarity between the physics 1 and 2 and the physics C questions, but the physics 1 has some specific things that aren't involved in the physics C questions. So one of them is here, which is what we call paragraph length response, which is so typically, most of the AP physics questions are multi-part questions. So they give a premise and then they have like 6 parts. Here, this is for the paragraph length response, this is the entire question. So they basically give a premise here. So there's a block on this slide, and then the block is allowed to slide down the ramp, and they ask some questions about its movement. And then basically there's a trial 1 where the slide part doesn't move, and trial 2 where the slide does move, and you're basically asked to analyze how those two situations different. Now, whereas in a lot of questions they would ask that same premise, but then they would say, okay, well, how is this going to be, how is the momentum going to be changed? How is this going to be changed? In the paragraph length response, they just say, indicate your answer and then justify your answer in a clear, coherent paragraph length explanation. So in these situations, you can use equations, but you can't. That can't be the only thing you use. Your answer has to be a paragraph. You can't. So you have to write out a full-length paragraph in order to answer the question. And they've added these to kind of show your your physics skills that go beyond just writing stuff out like a math problem. They can explain things the way you would have to on a lab report, let's say. This one is particularly tricky for this question right here is particularly tricky because there's a lot of times there's like 1 or 2 follow-up questions. On this one, all 7 points are for your paragraph, and they're looking for specific things. Like for example, on this one, you get a point for mentioning conservation of energy in any way. You'd get a point for this one. You get a point for talking about the potential energy being converted into kinetic energy, and so on and so forth. So it's a process of learning how to look for, what physics concepts are they gonna want. Even if I don't get the correct answer, I can still talk about the physics concepts that I know and get points for those. Another specific thing they have in the physics 1 test that that doesn't really show up on the physics C is this kind of verbal reasoning types of questions. So this one, they basically give a premise where we have a series circuit and a parallel circuit, and they're basically looking at how are the light bulbs different. So this kind of shows the laboratory nature of it as well, in that basically this is an experiment that you would have done if you'd taken physics 1. So they're kind of assuming that you have kind of a instinctual knowledge about how this experiment is going to go and what's going to happen between these bulbs. And then they give the premise, and then they have these things that student 1 and student 2 say. So typically they're almost always partially correct and partially incorrect. Sometimes they're one or the other, but usually it's partially correct and partially incorrect. And then what we can see down here at the bottom is the actual question, so which is which aspects of student 1's reasoning, if any, are correct. So even though student 1, their actual premise that they say bulbs A and B will be brighter than bulbs C and D is actually wrong, but they say that in a series circuit, each bulb gets all the current coming out of the battery. And that's true because in a series circuit, all of the current will go through each bulb one at a time. So the correct answer to that one, you would get points for pointing out that, for citing that information, that they say that the current bulb is correct, even though their answer is wrong. And then it would follow, which aspects of student 2's reasoning are correct, which aspects of student 1's reasoning are incorrect, so on and so forth. And so that's a type of question that's unique to the physics 1 test. Here's a kind of a typical physics C response. So we have a harmonic oscillator that's going back and forth, and we're asked to determine the equation for V of t. And so we'd have to use our physics knowledge to know that the equation for V of t is going to be V max times the sine of omega t, being the angular velocity. And then we'd also have to bring in our own knowledge to know that omega is going to equal 2 pi divided by the period of oscillation. We then have to go to the graph because they're asking us to determine it from the graph, which will show that it has a max velocity of 0.16 meters per second, and the period is about 0.7 seconds. And so we would bring those pieces of information into these equations that we've already written out and use that to derive our equation. So that would be the answer. And then the questions are typically scored, and this is similar to the way they score things in physics 1 and 2 as well. But they would give a point for knowing the original equation and picking the correct sign of that equation based on the shape. So if the sine graph had gone up and then down, we would have the opposite. So a point for that, a point for knowing that we need to use the relationship between period and angular frequency to find that, and then points for pulling information out of the graphs. And then we see in part B that we have to find the equilibrium. We have to find the equation for the position, which again requires using an integral to solve for that. So yeah, this is and these same types of questions you'll see on physics 1, but in physics C, this is all basically the only type of question that you would see. Okay. So as far as the courses that are offered, so there's this year we're planning on doing a physics 1 and a physics C mechanics course. So these are basically reviews for people who are getting ready for the AP test for this year. So there's going to be a few courses where it basically is doing a review of the concepts and the basic skills, followed by 4 mock tests and the review of each one based on the scores that people receive. And again, those are designed for people who are currently enrolled in AP Physics and are planning on taking the test this year. Another class that we offer is SAT Physics. So this is kind of a review of all of the topics that are involved in the SAT Physics course, and basically, everything from the mechanics stuff that pretty much everybody knows to the modern physics things that usually aren't covered in most high school physics courses. And so we cover all of it, and then we basically have embedded practice. So it's like one or two slides of concepts, and then another 1 or 2 slides of questions, and then at the end we finish it off with a full mock test and review. So just to give a quick example of what that would be, so we would go through this slide which talks about basically the magnetic field generated by current carrying wires. So we talk about the concepts on this one, the right hand rule, which basically governs what direction the magnetic field would be directed, and then we talk about the equations involved. In the SAT physics, you don't necessarily you don't necessarily need to know the exact constants and all that, but what you would need to know is the relationship. So for example, in this equation for the magnetic field, so magnetic field equals this, this constant mu naught, which is the permittivity of free space, times the current over 2 pi r. And so a lot of times you'd see questions that have to do with what would happen if the current was doubled, or if the distance, the radius was cut in half, or stuff like that. How is that going to affect the strength of the magnetic field? And so it's good. And so it's good to at least have seen the equations that those come from. And then we would go into a practice problem. So like this one, so electrons are moving in a wire, they're moving upward. And so this is kind of a trick question, because then the electrons are moving upwards. So that means that the current is pointed downward. And so we use the right-hand rule to determine that the magnetic field would be coming out of the page, which would be perpendicular to the plane of the paper. So that's the answer for that one. All right. And then just some general test prep and test taking tips for the AP physics. So I would say when you're preparing for the test, when you're studying, focus on perfecting your processes and your skills, not just the concepts. So you can know all of physics, but if you don't know how to apply those things in the ways that they ask you to on the AP physics test, then you're gonna struggle. When you're going through free response questions, ask yourself, where are the points for this problem? Even if I don't know how to solve it, what equations, what knowledge that I can put down on the paper would earn me a few points. For physics 1, you only need 63% to get a 5 on the test, and you only need 50% to get a 4. So, and then actually in physics C, you need even less points than that. So it's not about panicking to try and get every single point the way it would be on, like, say, the SATs, where you want to get every single question correct. It's trying to get as many points as possible on everything that you on every question and free response that you're going to do. For the SAT physics, I would say focus on broadening out your content knowledge, so that so you've studied all of the different topics that are going to be on the test. Some common ones: magnetism, people haven't studied a whole lot of; thermodynamics, waves and optics. A lot of times people haven't seen the geometric optics or ray optics. And then also nuclear and atomic physics, and some of the contemporary physics topics are things that people haven't seen before. And then make sure you practice through all of the concepts, because although you say, okay, I have a very good knowledge of the mechanics stuff, you may have forgotten how to use a couple of equations together. And so just practicing through everything will help you remember all that. And on the subject tests, unlike on the for example, the math test, you can't just guess, because they will take points off for incorrect answers. So unless you can eliminate at least a few answers, you wouldn't want to guess on the SAT test.
Awesome.
Okay.
Yeah, thank you, Colin. So we're
Yeah.
going to go ahead and move on over to a little bit of Q&A. If parents or students that are watching have any questions for Colin right now, you can also put it in the chat box or a Q&A box. But for right now, we'll answer some of these questions that students and parents have sent to us personally. So you can choose 1 or 2 to answer, Colin, because of the time constraint, but you can pick which you prefer.
Okay. So first question, which of the AP tests is the most difficult? I would say that depends on what your skill set is. So physics C is definitely more mathematically challenging. It requires you to have a good calculus skills in order to do that. But it isn't necessarily as challenging language-wise. So the physics 1 and physics 2 tests are definitely more challenging as far as your your English skills and your verbal skills. So if you're very skilled on the mathematics side, but you struggle a little bit with the language, then physics 1 and physics 2 might be actually harder for you, versus physics C. Whereas if you're good at working through the laboratory side of things, you're good at your lab reports, all that stuff, but you kind of struggle on the math side of things, then physics 1 and physics 2 would definitely be easier than the physics C. And then let me see. Good question. So how long should I spend on a free response AP Physics question? So that kind of depends. My recommendation is a good time is about what they recommend on each one, which is I think it's about 25 minutes. Well, on the physics 1, it's like 25 minutes for the longer questions and like 12 minutes for the shorter questions. It's a decent estimate, but really what I would say is you want to focus on the ones where you're going to be able to get the most points out of them. So focus on the questions where you have the best chance of succeeding on them. You obviously don't want to leave anything blank, so you want to leave some time to at least write down a few equations or write down a few concepts that on the other ones. But focus on the ones you're going to be able to get the most points out of, because like I said on the previous slides, you don't need to get every single point out of the free response questions. You just need to get as many points as possible. So focus on the ones that you can really show how much you know, and then leave some time at the end to kind of fill in the gaps and try to squeeze as many points out of the ones that you don't know as well. So
thank you, Colin. That was really helpful and very in-depth. Yeah. So we'll go ahead and switch on over to show some of the classes that Colin will be teaching in March. So thank you, Colin, for sharing. You're free to leave the room if you want to, or you can stay and also talk a little bit with people after if they have questions.
Okay, thank you.
Yeah, and then I'm going to go ahead and share the screen to show you guys the class that he will be teaching. Give me one moment. So if you go onto our website, 7edu.online/AP, our page is for AP courses, and we have a variety that is coming this March. So specifically for Colin, he will be teaching AP Physics 1, as well as our AP Physics C classes. And both of these courses are specialized and taught in small group classes. So students will receive the maximum and focused attention from Colin himself. And they're both structured with real practice tests and review. And then Colin will teach strategies to target individual weak points for every student. And if you want to know more about each of these courses that Colin is teaching in both March, you can go ahead and call our counselor, which is, phone number is 650-309-3458. Again, that is 650-309-3458. And then we're going to have Sherry, who is also one of our co-hosts right now, translate this for our Chinese audience. Sherry?
Yeah, it's me. 大家好，我是7edu 的 Sherry。如果大家有什么疑问呢，想用中文交流的，就可以随时找我联系我。我的联系方式是，我的电话是，可以在网站上找到我的电话啊。我的电话是650-309-3458，谢谢。如果有任何的疑问，可以随时联系我啊。OK。
Alrighty, thank you, Sherry. If anyone has any further questions or a chat box, go ahead and add it right now. If not, we'll go ahead and put our ending flyer for you guys.